This is Honors Geometry, section 16.1, looking at trig functions using degree angles. There are a ton of terms in this section. That's 2,000 pounds worth of trig functions. Oh, I'm sorry, of definitions, terms. Initial side of an angle. A ray in an angle that remains fixed. Terminal side of an angle. A ray in an angle that rotates. So let's illustrate this. Let's say that I draw this ray right here, and let's say that's the ray that's not going to move. That's called the initial side. If I then take another ray and I start moving it to form this angle, no matter where I stop, once I do stop, that's the side that rotated. That's called the terminal side. Every angle that we're going to be discussing will have an initial side and a terminal side. Well, you're probably wondering, if I have a static picture like I'm looking at right now, and I don't have the words on there, how would I know which one moved? Well, we often draw an arc with an arrow on it to denote movement. So the initial side is where it started, and it moved to be that terminal side in quadrant 2. Let's draw another picture. Let's say that we have the initial side on the positive x-axis again. And let's say that instead we start moving in this direction. And this ray that I'm moving is still the terminal side. The blue one is the initial side. To denote how it moved, we draw an arc with an arrow on it. So those two terms, initial side and terminal side of an angle. There are positive and negative angles. Up to this point, I believe in your mathematical career, you've only had positive angles. Let me explain. Let's say that our initial side is on the positive x-axis. If our terminal side is formed by rotating counterclockwise, that's the opposite way that a clock goes. That is called a positive angle. So in this case, let's say this was a positive 45 degrees. We could have the initial side on the positive x-axis, and we could rotate our angle in the clockwise manner, end up in the same position. We would denote that we went in this direction. How many degrees do you think that would be? According to this, if you rotate clockwise, it's a negative angle. So how many negative degrees would that be? That would be negative 315 degrees. How do I know that? A complete revolution is 360. If we went 45 degrees here, we'd have to go another 315 to get all the way back to the beginning. So negative 315 and then negative 45 more would get us back to the beginning. Let's discuss standard position and quadrantal angles. Standard position, an angle with its vertex at the origin. So here's a vertex at the origin. And its initial side on the positive x-axis. That's why I've been drawing the initial side on the positive x-axis every time so far. That's standard position. The terminal side, it could be any place. It could fall in any position, and that's going to be standard position. Quadrantal angle, an angle in standard position. So that tells us right away that the initial side is on the positive x-axis, vertex at the origin, whose terminal side coincides with one of the axes. So, for example, this is a quadrantal angle. It measures 90 degrees. Whoops. This is a quadrantal angle. It measures 180. This is a quadrantal angle. It measures 270. This is a quadrantal angle. It could be 0 degrees or 360. So this is a quadrantal angle. Before we continue, I just want to discuss some things. Let's go back up here to positive and negative angles. It probably was strange for you to see that a positive angle goes the opposite way a clock goes, and a negative angle goes the same direction a clock goes. If you remember how we labeled the quadrants in the coordinate plane, top right was quadrant 1, and then 2, and then 3, and then 4. That's going in the positive direction. So that's consistent. Also, we call the positive x-axis 0 degrees. A complete revolution is 360 degrees. If we go halfway around, we're at 180 degrees. Halfway between 0 and 180 would be 90 degrees. So if you look, it goes 0 to 90 to 180. 90 more is going to be 270 degrees. And then once you go all the way back to the beginning, you're at 360 degrees. I just thought I'd mention that. If we went in the negative direction, we'd be at 0 degrees, negative 90 degrees, negative 180, negative 270 degrees, and negative 360 degrees. Before we forget, it's super important that you use this degree symbol. If you don't use a degree symbol from here on out, it is assumed that you're not using degrees. So if you intend to use degrees, you have to use this symbol. Coterminal angles. Co means together, terminal means the terminal side. So the terminal sides fall in the same positions. Two angles in standard position whose terminal sides coincide with each other. So for example, let's say this is our initial side on the positive x-axis and our terminal sides on the positive y-axis. We could get this angle by going in the positive 90-degree direction, or we could go in this direction in the negative 270 degrees direction. So we could say that 90 degrees and negative 270 degrees are coterminal angles. Another example. Let's say that we have an angle here. Why do I do that? So we have this angle here in standard position, and it falls into quadrant 3 so that it makes a 225-degree angle. We could get to that same terminal side by making a complete revolution, that's 360, plus 225 more. To denote that, we could draw that we went around and then around until we stopped right here. That would be 360 and 225. That would be 585 degrees. 225 degrees and 585 degrees are coterminal. Next, degree. An angle has a measure of 1 degree if it results in 1/360th of a complete revolution in the positive direction. We could say that simpler. 1 revolution is equivalent to 360 degrees. This is super important. That makes half a revolution 180 degrees. That makes a fourth of a revolution 90 degrees. That makes an eighth of a revolution 45 degrees, etc. Draw a circle with radius 1 whose center is at the origin. Let's do that first. Here's an y-axis, here's an x-axis, and here's my circle. So the center is at the origin. and it says the radius is 1. Then label each angle around the circle counting by 30 degrees and then do the same for 45 degrees. Let's do it by 30 first. So the positive x-axis, we start at 0 degrees. And then we know from here to here is 90. So if we're going to count by 30s, we're going to divide this 90 into 3 equal parts. So let's say here-ish is 30 degrees. And then if we went about the same distance, that's 60. So we're saying 30 plus 30 plus 30 is 90. If we do the same thing here in quadrant 2, you're going to get 120. We're going to get 150. Try your best to make those gaps the same. They're not going to be perfect. Mine certainly aren't. So to get these numbers, you add 30 each time. 0 plus 30 is 30, plus 30 is 60, plus 30 is 90, plus 30 is 120, plus 30 is 180. 120 plus 30 is 150, and then 180. And then we're going to get 210, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and then back to the beginning is 360. We're supposed to do the same for 45 degrees. Well, if you look at the 90, 45 is going to be halfway between it. So we got 0, 45, 45 4 is 90. We already got that. 45 plus 90 is going to be 135. (135) plus 45 is 180. 180 plus 45 is 225 degrees. 225 plus 45 is 270 degrees. 270 degrees plus 45, that's going to be 315 degrees. And then 315 and 45 is 360 degrees. I would expect a quiz over this tomorrow, where I ask you on your own paper, draw a circle with radius 1, whose center is at the origin, label each angle around the circle counting by 30 degrees, do the same for 45. And you would draw this picture. You would not have to label 0, 0 as the origin. You should label the radius as 1, and then you should count by by 30 degrees from 0 and by 45 degrees from 0, all the way around until you get back to 360. Let's see if we can do some actual problems. Example A, draw an angle in standard position. That means the vertex is at the origin and the initial side's on the positive x-axis. And identify the quadrant in which the terminal side lies. Well, it's got to start out this way for each of these because it's in standard position. -12 means going in the clockwise direction. Now, a lot of times it is helpful to label your quadrantal angles. I'm going to do that. We got 0 degrees, -90 degrees, -180, -270, and then -360. -12 falls between which pair of numbers? Well, it falls between 0 and -90. So there's our angle, and then identify the quadrant in which it's in. So it is clearly quadrant 4. Number 2, 570, that's more than a complete revolution. So I'm going to label my quadrantal angles again. So we got 0 degrees, 90 degrees, 180, 270 degrees, 360. Now it doesn't help yet because I need to get to 500 past 570. So if I had 90 more, 360 and 90 more is 450, plus 90 more is 540, plus 90 more is 630. 570 falls between 540 and 630. So I make a complete revolution, and then I'm going to go a little bit more till I get in quadrant 3. And that is my 570 degrees. B, find the measure of each angle in degrees. Well, this is kind of like the angle addition postulate. From here to here is 180, but we are going to be 30 degrees short of 180. For 30 degrees short of 180, that must mean this is 150. 150 and 30 is 180. Down here, this is in the negative direction. We're assuming these are in standard position, so it went this way. So we know our answer is going to be negative. From here to here is 90. Here to here is 15 more. That makes this whole angle negative 105 degrees. Number 3, this is a complete revolution to here, that's 360. If we go here, it's 90 more, that's 450. If we go here, it's 90 more, so now we're at 540. And then this whole thing is 90. We've used 70 of it. So how much is left here? It must be 20. That makes this whole angle 560 degrees. Number 4, we are going in the negative direction, so I know our answer is negative. From here to here is a complete revolution in the negative direction. That's a negative 360 degrees. If we come down here, it's negative 90 more. That's negative 450. And then we're going negative more at 25 degrees. It's going to make this negative 475 degrees. Example C. Example C is always so excited to be around. I mean, look at that smiley face. Find one positive angle and one negative angle that are coterminal with each angle. Now let's discuss once again what coterminal means. Two angles in standard position whose terminal sides coincide with each other. Coterminal angles, what do they have in common? They are complete revolutions apart from each other. Remember, revolution is equal to 360 degrees. So if you want to find a coterminal angle, you add or subtract complete revolutions to the angle you're given. You could add 1 revolution, you could add 50 revolutions. There's an infinite number of answers for these questions. So for a positive coterminal angle, I'm going to take the angle that I'm given, I'm going to add to it a complete revolution. That's going to give me 460 degrees. So that's an answer. For a negative one, I'm going to subtract a complete revolution. That would be negative 260 degrees. D. This is a terrible example. Find a coterminal angle between 0 and 360 degrees. Let's change this problem to negative 700 degrees. Negative 70 is just too easy to do, and it gives a false impression of what these questions are asking. So to find coterminal angles, I'm going to add or subtract complete revolutions. I want an angle between 0 and 360. This is already much smaller than 0. So I want to add a complete revolution to this. If I do that, negative 700 plus 360, that's going to give me negative 340 degrees. Is that between 0 and 360? Sure isn't. So I'm going to add another revolution to this. And that's going to give me 20 degrees. That is between 0 and 360. Another way to do this problem, if you prefer, is you could take negative 700 and add to it 720 degrees right away, because 720 degrees is 2 revolutions. As long as you're adding or subtracting complete revolutions to this, then that's going to work. All right, that concludes the notes for 16.1. Please do the homework that accompanies this and have a wonderful